In this video, we're going to discuss CRA models for whole number multiplication. So we're going to look at 4 different types of models, but first we're just going to start with one of the most common schemas for interpreting multiplication, which is that equal groups. So again, how we want to interpret our multiplication equations or expressions is that first multiplier is telling us that's the number of groups, second multiplier is the size of each group, and then the total number of pieces or the total length, depending on our model that we're looking at, or the total area, is our product. Okay. So the first type that we are going to look at is going to be called a set model. Okay, so similar to addition and subtraction, but we're not measuring any dimensions here. We're just counting the frequency or the number or the amount within or the amount of objects. So with multiplication, again, with that group structure, so this is a concrete model. You can use any object. This is an example of a set model for 3 times 4 equals 12. So there's 3 distinct groups that each have a size of 4, and there's a total of 12 counters. And so that's a concrete set model. A representational set model would be something similar. I'm just going to do an easy one. So circles is going to be the groups, and then just the dots within each group. That's the size of each group. So there's 3 distinct groups that each have a size of 4. So that's 3 times 4, and that's a total of 12 dots. So 3 times 4 equals 12. And then the abstract model is just going to be the actual equation written out. Again, making connections to the groups as that first multiplier, and then the size of each group as that second multiplier. So that's the set model. The next type, which would be similar to addition and subtraction as well, is going to be a length model. So with our length model, we are actually measuring one dimension. We're measuring the length of some quantity. So here again, we can see 3 separate lengths, right? The yellow, the red, and the blue, that each have a length of 4. So again, this yellow is one group, red is one group, blue is one group, and then the size of each is going to be 4, and this has a total length of 12. So again, length model, we're measuring the actual length. So that's these are just the connecting cubes. It's common tool used for length models. Okay, since you can kind of connect and disconnect as you need. And then for length models, common representational model is going to be our number line. So for multiplication, we might just show each group kind of as different hops, or you might have different bars that are drawn right next to the actual number line. But either way, we can see we have 3 different groups that each have a size of 4. So 3 times 4, and it has a total length of 12. And then again, the abstract model, abstract's going to be the same for all of these. 3 times 4 equals 12, again, making connections to that group structure. And the new model type that we haven't looked at for addition and subtraction is an area model. So an area model, so again, with the set model, we're measuring 0 dimensions. Length model, we're measuring 1 dimension. Area model, we're measuring 2 dimensions. Okay, so we have a length and a width or a height or whatever terminology we want to use here. Okay, but with an area model, what will kind of set this apart from what we'll look at as our 4th model is that we don't have any gaps or any overlaps. So we're actually measuring the physical area of this space with some kind of square units. Okay. So in this, kind of how we could interpret that group and size structure, how I have this oriented right now, if we're looking at 3 times 4 again, is that each row, so going across, each row is one group. So there's 3 rows. And then the number of columns or the number of objects in each row is going to be the size of each group. Okay. We could just as easily say that the columns are the number of groups, and if we wanted this to be 3 times 4, we would just rotate this 90 degrees. Right, so if we wanted to say that the columns were the groups, right, we could say we have 3 columns, each have a size of 4. Okay. But any kind of tiles or cubes or just units that are square that are all the same size are going to be common tools for the area model. So that's a concrete model, just with some cubes. And then for area model, it'll just be common to have drawings that are pretty similar in structure. to the actual area model. And so here we can see that there's a height of 3 and a width of 4. So again, we're 3 rows that each have a size of 4. And then the abstract model again is going to be 3 times 4 equals 12, because we have a total area of 12 square units, or 12 cubes, or 12 squares in our concrete or representational model. Okay, so again, the groups for our area model could be rows or it could be columns. You could make the case for either. Okay, so it's area model, and then we have one last type, and this is going to be an array model. So one way to think of this is kind of the marriage of a set model and an area model. So this is a set model that is organized as an area model. What sets it apart from an area model is you can see there's gaps that are in between here. So we're not actually measuring the area of this. We're still just counting the number of objects. It's just organized in that row and column structure. Okay. So any sort of object basically that's not a square unit that is compressed all together would be some kind of tool you could use for an array model. So any tools that you would use for a set model are also tools you could use for that concrete array model. So again, 3 rows of 4, or if we wanted to say, right, 3 columns that each have a size of 4, either would work for that concrete model for the array model. Okay. So that was the concrete model. If we look at a representational model, again, it'll be kind of similar to the concrete one. I'm just going to use X's because those are a little bit faster to draw, and I'll just do the rows. So you have 3 rows that each contain 4 X's. So again, we have 3 rows of 4, and there's a total of 12 X's. And then, just like the other 3, the abstract model, 3 times 4 equals 12. Again, making connections with that group structure, kind of similar to the area model. The array model, that group could be either the rows or the columns.